This is Electric Universe Eyes, and today I'm going to talk about the legendary Tesla coil. Tesla had used coils and capacitors when experimenting with rotating magnetic fields for his motors. He continually refined the components, particularly the special transformer, or coil, at the heart of the circuit, taking out his first patent for a device to run a new and more efficient lighting system in 1891. The basic circuit connected a power supply to a large capacitor, the coil or inductor, and the electrodes of an adjustable spark gap. As the capacitor charges up, the voltage lags behind. In an inductor, voltage is felt immediately while current is held back as it has to work against the magnetic fields its own passage causes. If the size of the coil and the condenser are selected to have exactly opposite timing, with voltage peaking in the capacitor just as it reaches a minimum in the coil, current and voltage can be made to chase each other back and forth. This oscillation is initiated by the spark gap. When the voltage in a capacitor builds up, it reaches a level when the air in the gap, which acts as an insulator, breaks down due to ionization and lets current flow. In a Tesla coil, the inductor is the primary coil of a transformer. When the circuit sparks, all the energy stored over several microseconds is discharged in a powerful impulse, producing a high voltage in the secondary coil. Once the energy has been discharged, the voltage across the spark gap falls and the air becomes an insulator again, until the voltage in the capacitor builds up to the required level again. This whole process can repeat itself many thousands of times per second. In a Tesla coil, secondary winding is designed to react quickly to a sudden energy spike. These electrical impulses propagate along the winding as waves. The length of the coil is calculated so that when the wave crests reach the end and are reflected back, they meet and reinforce the waves behind them. So it appears that the voltage peaks are standing still. If the high voltage end of the secondary coil is attached to an aerial, it becomes a powerful radio transmitter. In the early decades of radio, most practicable radio transmitters used Tesla coils. Tesla himself used larger or smaller versions of his invention to investigate fluorescence, X-rays, radio, wireless power, and even the electromagnetic nature of the Earth and its atmosphere. That's right, we live in an electric universe. Tesla was advised to play down the possibilities of his wireless system. It seemed so fanciful it might deter conservative businessmen who might otherwise be interested in his motors or his lighting systems. Nevertheless, he said, it earned him the title of Father of the Wireless among fellow researchers. Others had investigated the phenomenon of wireless transmission before him, but Tesla had pioneered the use of the tuned circuit, the aerial, and the ground connection. He was giving these demonstrations of wireless transmission a full year before Guglielmo Marconi even began experimenting. In 1896, Tesla received a letter from Sir William Preece, 1834 to 1913, of the Imperial Post Office in London, asking Tesla for 2 wireless sets for trial. But Marconi was in London by then. He intervened, telling Preece that he had tried the Tesla system and it had not worked. Nevertheless, Tesla filed a patent for wireless transmission in September 1897. This was an excerpt from Tesla, The Life and Times of an Electric Messiah, written by Nigel Cawthorne.